Okay, equation of a perpendicular line. So example 4 says find the vector equation that is perpendicular to this vector here and passes through this point 6 and 5. Okay. Now we got to remember back to our previous chapter. Equations that will give us perpendicular lines. Anyone remember what equation helps us find perpendicular lines? Cross product is one. There's another one that's a little simpler to use, and it's going to equal, yes, dot product. What will it equal in that case?
0.
It'll equal 0, okay? So if you guys remember your dot product formula, we have dot product of two vectors, so we'll call this vector R, and the perpendicular vector P is what we're trying to find. The dot product will be equal to 0 in their case, okay? So we can multiply the components of them. We don't know what perpendicular vector P is, so we're just going to call it A and B, okay? Those are the components of vector P that's perpendicular. We don't know what it is, so we'll try to find them. We do know the point for it. In our vector form, when we do find vector P, we know that our point is going to be equal to 6 and 5, and is going to be some scalar of A and B. Well, we do have the direction to our perpendicular vector, which is -3 and 2. So what we're going to do is our directional vectors, our R, is -3 and 2, and the dot product of A and B. Our directional vectors have to be perpendicular to each other, so we know the dot product between the two of them will be 0. Calculating dot product, we just multiply our x value, so -3a plus 2b will equal 0. Now, we talked about this before with directional vectors. Because they have parameters or scalars to them, there's an infinite number of directional vectors. They're just scalars of the others. Just like here, A and B, we can find many different solutions to A and B. We're going to try to find the simplest one. Okay? So we need to make this some number, that is maybe negative, of the other absolute value. The easiest way to do this, because our 3a is negative, if we make A the number 2, and we make B the number 3, when we end up multiplying the two, we'll get -6 plus 6 is equal to 0. Okay? So we just took the coefficient of the other variable, or the number that was in front. So these are now going to be our directional vectors. Okay? Our directional vector is going to be 2 and 3 as our values. So we take A, like we said, was 2 and B was 3. We're going to plug those in for our directional vector of our perpendicular equation. So our perpendicular equation is 6 and 5 plus T, 2 and 3. And if you guys remember back from grade 10, when you're trying to find perpendicular lines, if you had slope, let's just try to refer this back to slope. This would have been a slope of -2/3 for our vector R. If I'm finding a line perpendicular to that, does anyone know what I do to the slope? Negative reciprocal. What would the negative reciprocal of this be? 3/2, right? And that would be our y value and our x value, which is pretty much how we plugged it into here. Okay? If you're confused on how to do that, you can always refer back to the slope form in order to find perpendicular lines of it.